Yeah, because watch your video yesterday. They were trying to be like, yes, that's right.
Yeah, they had a whole thing.
Me either. I didn't get about it either. Yeah.
False. He was in basketball.
I was not.
I know.
No, he literally admitted earlier that.
And I
even
was
if we
not.
didn't invite him, he wouldn't have gone.
Oh.
He said it. That was pulled up.
Yeah, we probably could actually. You can pull up the video. I know from experience. Anyway, all right. Homework. How did you find f of 21? What'd you get for f of 21? 2. Okay. How'd you get it?
I divide 21 by however much the period is.
Mhm.
And then, like, whatever remainder I have, then I go to that, and then wherever the bottom is.
That is exactly correct. All right. Good. So what did you get for f of 30? -2? What'd you get for f of -25?
-3.
Fantastic. How about g of -64?
-4.
G of 84?
3.
And g of 34?
5.
Okay. So then we just talked about how you use the function value or the period of the function to find the function value. So we just said that you're just looking at the remainder. Okay. So 8 on, you had to come up with your own function. So everyone could have a different function and you could all be right. Okay. On number 8, period of it had to be 7. Number 9, you had to make a function that was not a periodic function. And then for 10, you had to do the domain and range, and 11, you had to sketch it. Any questions about just the basics of a periodic function? No? Okay, good. All right, so today we're going to develop and analyze the graphs of the 6 trig functions.
They're back.
Yeah, they're back. But now it's the graphs. Now the pages are totally off because this is page 716 and it says 743. So I'm not really sure. So yours says 715 right there?
Mine says 43.
Mine says 743.
But on pages.
Oh, yeah.
Anyway, okay. So anywho, this is actually the last page that you do. It's first, but it's last. It's biblical. But we're going to start here. And then what you have to do is you have to graph all these things. And then after you graph them, you come back and you do this. So I guess you could do like sine and then sine. And then you could do cosine and then cosine. I guess you could do that. I don't know. I don't really care how you do it. But you have to do the graphs first. You can't answer the questions without doing the graphs. Where do you think I left my pencil?
You need to borrow one?
I have like 7 of them.
Yeah.
If I can just locate them.
Did you look under that?
Oh, I found one.
All right. What's the sign of 0?
0. No, I'm sorry. Sign is Y, right?
Why is it just because I don't answer you automatically think you're wrong? Can we be confident in our
0.
answers?
What?
Y
Why
is sign.
is sign because?
Y is sign
Because.
because sign is also odd, which is the exact same.
You're saying y is anyway.
It's 0.
0.
Yeah.
0.
Okay.
Vivian. Remember he said
This was.
I was still confident.
What is the sign of pi over 4?
2 over 2.
We're gonna need an estimate on that. We're gonna need a decimal estimate. What is the decimal estimate of square root of 2 over 2?
So less than 1. Yeah. Less than 0.5. No, it's above 0.5. Somewhere between 0.5 and 1.
Why do you know it's less than or above? Like, how do you know that?
Well, I know square root of 2 will have to be less than 2. Because 2 over 2 equals 1. The square root of 2 has to be less than 2. So, I mean, no, it has to be less than 1. And I know 1 times 1 is 1.
What's the sign of pi over 3?
Sine of pi over 3, 1 half. No, square root of 3 over 2.
Okay. What's the sign of pi over 6?
1 half.
So then it has to be
Yeah.
less than 1 half. That's what I was going for, not all this. Okay. I'm not, you can find out. We need decimal estimates of all these. Go ahead and figure all those out.
0.70 or 0.71.
Yeah, I thought you said do your best in the silver. Not
So do you only want the decimal? Or should we put both?
We're going to graph it, so you really just need a decimal.
That the one Derek did isn't.
I got 1.5.
Square root of 2 over 2. Is that what we're doing?
Square root of 2. Oh, I put that in the wrong place,
Yeah.
by the way. Sorry. That's all. I just put it in the wrong place.
One, right? That one's 1, right?
Is it?
Yeah.
Okay.
That one was 171 also, right?
This one?
Yeah. And 0 again. Negative. -1. Yeah, 0.71. 0.
I don't know if that's crazy.
So 0.71 1.71 0 negative 0.71 negative 1
You don't set up the thing that was on the test. Is it?
I don't know.
oh, we have to do all the way to 4 pi. Well, what's gonna happen here?
So to start over.
Yeah, it's just gonna start over. So this is one what? What is this called? One period of the function. All right, I'm gonna show you like a cool thing.
Is it a tool?
It's gonna do the same thing over and over again. Okay, so if you continue to go around the circle,
It's like the thing on Grey's Anatomy.
Oh, that is crazy.
Something weird.
it just does the same thing
I kind of like it. So
over.
every time it goes
make it
around
stand
the
yet?
circle, one period.
Mhm. So it, let's just say it's starting here, and then it goes.
It's the 1.
Oh, every half.
Well, is that half?
Oh,
no.
There we go.
Now.
Now it has, yeah. Now it's starting back where it was. Right. Okay. And someone said, yeah, no, Jonathan. Someone said something about Grey's Anatomy. That's actually true. Your heart is in a sinusoidal rhythm,
Duh.
and if it gets out, you're in trouble.
What's the sign you?
She's mixing Greek house
Sign
right
you
now.
feel
Goodness.
What's
Yeah.
the sign you settle?
There you go.
This is that periodic repetition that's happening. Yeah. All right. So back to this. Now go ahead and finish that to 4 pi.
Oh.
It's a hard
How come they're only using over 4?
How come they're only going to 4? Just to show you that it keeps.
No, just like those. Why didn't they use like pi over 3 instead?
These are easier to graph.
Oh, okay, so it just doesn't matter.
Mhm. Okay, so things to remember. Let's just think about this for a second before we fill anything out, before we start doing cosine. Cosine and sine share the same numbers, right?
Yeah.
Are there going to be any different? Will there be any differences?
And will it go the opposite way?
I don't know. Will it? Let's talk about it.
Like, instead of starting there, it would start.
No.
Is it going to look exactly like this?
No.
What's it going to look like?
But the inverse of it? No.
It has an inverse.
Well, let's say it'd be 0.
But-
it's gonna be an inverse would be.
Where would
Yeah.
cosine, where's cosine going to start?
Let's just start at 1.
Cosine's going to start at 1. So cosine's going to start here.
And it's gonna go down, and then, yeah, so it kind of.
So it's going to be like this, sort of shifted over a little bit, right? Okay. All right, good. Let's fill out this part. What's the domain for sine? Like, yeah, it's continuous. You should have carried this on and you stopped at 4 pi just because it told you to. Does this actually stop at 4 pi? No. It goes on as many times as you can go around the circle, it's going to go. So if there's any number at all that you want to put in there, you can. What about the range? Negative 1 to 1, and that is inclusive. How about the period of the function?
2 pi.
2 pi. Let's see. It starts over at 2 pi.
Don't know this one.
Does it have asymptotic behavior? No, it doesn't. But this leads me to believe that some of them might. Some of them are going to have asymptotes. Which ones do you think will have asymptotes?
Tangent and cotangent.
Tangent, cotangent. Why?
Because
Because some.
I kind of just guessed it.
Because what? Eventually they're going to be 0, right? Yeah. You think those are the only ones that are going to have asymptotes? Tangent and cotangent?
Probably not because of the way you're saying it.
Wherever the zero is, probably right?
Yeah, whenever there's a 0 in the denominator. So like when we do secant or cosecant, those will as well. Okay. I feel like you could probably do cosine without me since I just did sine with you. So go ahead and do cosine without me. It's really, you're supposed to do all of these without me, but since we're also trying to record this for baseball people, I'm doing more than I'm supposed to do because so I'm gonna let you do cosine and then I'm gonna just pick some ones to put up here and show what it looks like when it's done. What the heck?
I think I did it, y'all.
You know what? I'm gonna show this beautiful plot of a
I think I
cosine.
did it. It kind of looks like a hill.
It looks
Yep.
like that. There's a plot of a cosine. It starts at 1. It's here are the two of them together. Sine is yellow and cosine is blue. And it's really and truly it's just a shift. It's just like somebody went and shoved it over. Okay? So this is cosine right here. There's the cosine. All right. Can you answer the stuff on this page with cosine? What is your domain?
Negative 1 to 1.
Okay. What's your range?
Negative 1 to 1.
Okay. What's the period of the function? 2 pi. Are there any asymptotes? No, not this time. All right, are we ready for tangent? What is the tangent of 0?
5. No.
0.
0. Oh, 2 is in
What's the tangent for pi over 4?
1. No, it's in 5.
3 pi over 4? Pi?
0.
What?
1.
1 or negative 1?
Wait a minute, no, 3 pi
Yeah,
over
3
4
pi
would be
over
negative
4.
1.
Okay, thank you.
And then that'd be 1.
And then what happens?
0.
You
No,
sure?
Undefined.
5 pi over 4 is 1.
That's the negative over a negative.
Oh, okay.
The negative 1 is 0. No, yeah,
You sure?
yes,
Positive?
yes. No, negative 1.
And right now there will be a vote. There will be skits and there will be speeches. And they will have to be early because they're scheduled to be on the 17th, but we have semester tests on the
So
17th.
he's doing it?
Someone told me there's no treasurer for class office, and that's when.
Yeah. So let's just take a pause really quickly and let's just talk about this. So yeah, it's still blowing up. 11th grade is, do you see 11th grade? 11th grade. So,
That's what we should see this.
let's see. 8th grade. All right, maybe, I don't know. I think in one of the classes, it was listed as president, vice president, and class reps. It doesn't look like it was in the 11th grade class, so it's okay. Some people are just deciding to run for like whatever. Like, sergeant at arms or.
She said that way. I think you're right.
And Hunter's running for secretary.
Here we go. That's the ninth grade. Ninth grade, president, vice president, class rep boy, class rep girl. So, but that's fine. There wasn't anything in your class. You really can't do anything as treasurer because we don't let kids touch money. So, but yeah, I mean, you know, you're shooing. I didn't even put your name on the ballot.
Class rep.
So I don't know. I'd have to look.
So I might just like put
A little sticky.
I would treasure your vote for class rep.
Treasure is that.
Yeah.
Okay, but how good would it have been if Jessica made posters and put, if you don't vote for Jessica, you will perish?
I love it.
I know.
Yeah,
I know.
I love that.
No, here's what I did. I got a picture of me as the Grim Reaper, and I put
From
vote
the
for
car
me
wreck.
or you will die. And my dad was like, "There's school shootings happening every day."
That's like, throw them away.
Jessica, there was one yesterday.
And he was
Not a bad
He
time.
was like, "Why don't you just put Paris on there?" And then I come here and tell her that I can't do it.
And
'cause
she
it's
was like-
John's idea.
She was like, "That's such a stupid idea." I'm like, "That's the best."
Yeah.
one. Like,
I
that's
just
the best one.
told
That's my
Coach Moore at the
father's idea."
softball game last night, I was like, when your kid gets to high school, I need her to run for student council so her poster can say, we want more. Yeah. And she
Yeah.
was like, that's not happening. Yes, it is. It's gonna happen.
We went the same.
Yeah. So anyway,
Wait, so there's no secretary?
not really. There's not a secretary either, but
You can make up like senior
Can you
president.
tell Caleb
Right.
to run?
no.
Did you turn in all the stuff?
Yes.
Who's running?
Caleb.
Yeah. So anyway,
There's nobody running for that.
you don't have to do. If you were running unopposed, I did not even put your name on the ballot. So only the opposition.
Do I have to do this yet?
Yes.
No, it's not.
That's one reason I actually wanted to run for student council.
What should the skip be? Ideas.
I don't know.
Dude, I
I
would.
did. Oh, can I say I will be the first African American? Don't
You do
even-
it, I would.
Oh my gosh. I don't know. I was gonna say, your dad, wasn't he active in student council? Then you won't be. It's a dynasty.
You could do like a whole like
Yeah.
push thing.
Like Duck Dynasty. Like so did the Bush.
You could do
Yes.
like pushes. And like pop it.
I'm George Bush. And that's it.
That's it, I'm done.
Your dad to be.
No. He has a job and he's embarrassing.
Yeah. All right, let's go ahead and graph this. Okay. So at 0, it's 0. At pi over 4, it's 1. And then at pi over 2, it's undefined.
How do we know it's an asymptote and not a hole?
It's non-removable. Remember, holes are removable.
Wait, is this still on there? It is.
Oh, that's not it.
It was on the thing from yesterday.
What's on the thing from yesterday?
It is. It was like the first thing you noticed. Here, I'll go back to it.
Oh, I guess that's
That
right.
thing.
They'll always try and approach it.
That's not from just graph.
I mean, it's that same thing.
Yeah, okay.
Scoot it over.
Yeah, I just.
What are you grabbing?
This is it.
Oh, it's
See,
not.
yeah.
You got a big old U. There ain't no U on that
Why is that
screen.
the right
Why
one?
is there a U?
No, you.
Oh, I didn't think negative.
User later.
I'm just I'm ahead.
Use that be when it's exponent.
No.
No.
When there's a.
Good.
You can carry on. I'm not doing all of this.
No, it's really. Who can show up there? All your friends are gone.
All right, let's fill out this chart here. What's the domain for tangent?
It's not equal.
Okay, so we have to do one of these.
It's not equal to pi plus 2n. No, plus, wait, it's not equal to pi.
Where is my tangent?
Pi plus 2. On the back of one of them.
I think we talked about this yesterday and we said it was pi over 2n, but I think it's actually because, hang on, pi over 2n is where or pi over 2 is where the first one starts, but this is pi over 2 again, and this is pi away. So I would say pi over 2 plus pi, pi n. Because they happen every pi. They don't happen every pi over 2. See, this is every pi over 2. Here, 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 here. That's every half pi. It starts, the first one is at pi over 2, but the next one doesn't happen for 2 halves, which is a whole, obviously. Yeah,
Pi over 2
that's-
plus pi n.
That's how it needs to be written. Yeah.
Power 2 plus.
Plus pi n. Or pi k. You could say k if you like k's.
I like pi.
And here, let's go ahead and say k is going to be like -1, 0, 1, 2. Like, let's say what k is going to be so we know, because these are notes. This is not, this is for you. So you need to know when that's going to happen. So that's going to end up being like, again, this is notes. So that would be like x can't be pi over 2. It can't be 3 pi over 2. It can't be 5 pi over 2. What's the next one on your page?
7 pi over 2.
It can't be 7 pi over 2, and so on. Okay, so that's what you're saying right there. That's a lot to fit in that tiny little square, Mr. Sparks. What's the range? Yeah, you can put any, you're going to get every single number in the whole wide world out on that range for sure. Home on the range. All right, so where, what's the period of the function? Pi. And then the asymptotic behavior is pretty much what our domain is. You get an asymptote starting at pi over 2, and then it happens again every pi units away.
So you just put pi over 2 plus pi k.
You can do that, yeah. All right, so cosecant. Are all of you in A push, by the way? That's fun. No? You're not? You're not? Okay.
If you have class, I'll come.
Do we have to?
No.
I have no idea. If they say from the office that you have to be here, then I will teach class. So, because you have to be here. All right. Fill out this chart for cosecant.
You'll perish. Vivian, Vivian out. Could be Vivian in office, will be Vivian out of it. It's like for America.
You can hang it up.
Yeah, we're
I'm waiting for
the treasurer is a good job.
It exists in your heart.
Exists as much as a pet.
Not on the ballot.
Oh,
Oh, I'm in the yearbook. You shut your mouth.
heart.
You should have
What? I don't get it.
done that. Heart.
Heart.
Yeah. It'll break my heart. if You don't vote for me. Something like that.
Look, I had about like 5 packs of letters.
I had to buy more sparkle paper last night.
On the board?
Yeah. Found out I had to make more posters.
Are you done with this cosecant chart yet?
No, I'm still 0.
Oh yeah, it was like
Does class officers have to give speeches? It's weird.
Not unless their class sponsors one to.
You want a speech you got on this Vivian?
oh, Bailey did that one.
Yeah, vote. 4.
And he won.
Oh my gosh, yay! And your fingernail fell off.
She sounds like she feels really bad about that.
I remember your rest of the balloon.
It was like mess with the listener.
Oh,
I said like, what's that? We pointed at a rock.
Yeah, that's right. That's what I
it
got.
would be, no.
That's how I make friends.
Dark.
What'd you get for 0? What'd you get for pi over 4?
1.41.
Pi over 2?
1.
3 pi over 4?
1.41.
Pi?
Undefined.
Oh.
5 pi over 4? 3 pi over 2? Plain 1?
Never mind.
7 pi over 4? And 2 pi? All right, so it's 0.
Okay, that makes sense.
It's undefined, so you have this asymptote. Pi over 4, you're at 1.41. Pi over 2, you're at 1. And 3 pi over 4, 1.41. At pi, it's undefined. Draw that in, and then I'll go back. So this looks kind of like this. It's really actually a lot flatter on the bottom than I just drew it. It really flattens out here. And then at 5 pi over 4, it's negative 1.41. And then negative 1. And it keeps doing this forever. And then it does one of these jobbers here.
This is the first time I've shown this.
And it just keeps repeating this over and over and over again. I wish I drove a Tesla.
Would you actually drive the Tesla?
I might let it drive me.
Charge.
I wonder how many people use their Tesla as an excuse. Like, I told it to take me to work. I don't know how it ended up here at the mall. I don't work at the mall or Starbucks or anything else. You just end up. All right, can you fill out the chart based on this? I'm gonna let you try to fill out the chart.
I can do it.
I think you can.
I can do it.
I keep losing my chart. There it is. What was the bell ring supposed to call?
135.
Okay. That's a good idea. For my last email.
This is my education.
All right. So what'd you get? What'd you put for your domain?
H not equal pi plus pi n. Sorry, what's wrong?
Well, since it starts at 0, you could just put pi in on this one.
Oh, yeah.
I'll put pi k.
Yeah. All right. And then that n or that k, just so you know, that's going by integers.
2 plus 2 is 0 plus 4.
Which means it's basically tapping in at 0 and at pi and at 2 pi and on. What's your range?
Good.
Right. It's not all real numbers. It's definitely jumping from here to here. If you notice, okay, you can draw in the sine function
Oh, that's ridiculously awesome.
exactly.
It's everywhere. It's not.
Oh, that is so
Yeah.
crazy.
Yeah.
So the range is
Oh.
the
Yes.
exact opposite.
Yeah. Yeah.
Fine.
Yeah.
In between
Because
that.
remember, like, yeah,
Because they're opposites.
they're
So
opposite.
together it's negative infinity to infinity, and then it's infinity to infinity.
Oh.
I want you to do secant, cotangent, and that free response for your homework.
I can guess what secant would be.
Yeah, you could probably, I mean, it's, yeah. So, anyway, I want you to do secant, cotangent, and that free response for your homework. Everyone tell the baseball people bye.
All right.
Bye, baseball
You got this,
people.
Toby.